Hello class, welcome to 6.6 review. So let's go ahead and get started. So we got problem set number 1 says determine if it is possible to form a triangle with the given side lengths. All right, so really easy to do this. This is called the triangle inequality theorem. In order to do this, you have to take the two shortest sides and then you add them together. If it's greater than the third side, then that means that you can form a triangle. If you subtract the two shorter sides and it's if you subtract the two sides and it's smaller than the third side for all the sides, then it also forms a triangle. But the easiest way is just to add them. So add the two shortest sides, and that should be bigger than the third side, the longest side. Now, is that true? Well, 9 plus 12 is 21, and 21 is less than 18, so that's true. So yes, it is possible. Now here the two shortest sides are 13 and 14. So that's equal to 27, which is bigger than 19. So yes. All right, it's pretty straightforward. So let's look at the next one. Here we got 17, 9, and 8. So 9 plus 8 is 17, which is not bigger than 17. So the answer is no, it cannot form a triangle, okay? Here, the two shortest sides are 23 and 26, which is equal to 49, which is not greater than 50. So therefore, it's no. All right, and that's how you determine. That's really, really easy. So then this one, the two shortest sides are 32 and 41. So 32 plus 41 is equal to 73, which is bigger than 63. So yes. Two shortest sides, 3.1 and 2.7. That's equal to 5.8, which is bigger than 4.3. So yes. All right, really straightforward, guys. All right, problem set number 2 is finding a value of the third side that satisfies it so that you can make a triangle. All right, so 7 and 29 are my two sides, and then I'm going to find the third side. So, so what are some possible values? Well, remember that we can add the two sides, and if we add the two sides, it should be bigger than the third side. In other words, the third side has to be smaller than when I add the two sides, right? I can also subtract the two sides, and that number should be bigger, and the third side should be, like if I subtract the two sides, that number should be smaller than the third side. So if I subtract these, 29 minus 7, so that's how I do it. I just subtract them and then add them, and that gives me my range of values. So that means that x could be anywhere between 22 and 36, but it cannot be equal to 22 or 36. All right, and there's your answer for number 1. Really easy. So just add them and subtract them. All right, so x has to be less than 23 minus 18, but it has to be greater than 23 minus 18. So in other words, x is between 5 and 15, or I put minus, it should be plus, sorry, 23 plus 18, which is 41. So x is between 5 and 41, not including 5 and 41. All right, so we got sides 27 plus 13. It's got to be, x has got to be smaller than that, but x has got to be bigger than 27 minus 13. So that's 14. X is between 14 and 41. All right, or 40, sorry. All right, and that's it for that one, really quick. So now the next one is a couple of proof examples. So we can do this one. Okay, so let's look at the proof. So remember that here it says number 1, PL is parallel to MT. That was given here. So the reason has to be that it was given, right? So given. All right, and then, okay, so these are parallel according to that. So remember, if you see parallel lines, you want to think sandwich model, right? Parallel lines with a transversal. In this case, this is the toothpick, the transversal, right? So this is angle P is congruent to angle T. Well, what kind of angles are those? Well, if it's a sideways sandwich, P and those angles are inside the sandwich, and they're alternate sides, opposite sides. So they're alternate interior angles. So alternate interior angles theorem. What's another given? So another given is that K is the midpoint, right? So we can write that here. K is the midpoint of PT. All right, so let's say K is the midpoint. Well, then that means that this has to be the same on both sides, right? So that's the midpoint theorem. All right, and if PK is congruent to KT, that means PK has to be equal to KT by definition of congruence. And we got some vertical angles here for number 6. So notice that these two angles are vertical, right? So vertical angles theorem, angle PKL is congruent to angle MKT, or TKM, same thing. All right, so here we got angle, side, angle. Angle, side, angle. And so those two triangles must be congruent, right? So they must be congruent by angle, side, angle congruence. All right, so now they're congruent. So now we can say that KL, let me get rid of these A's now, because there's too much things going on. Now we can say KL is congruent to KM. Why can we say that? Well, because the two triangles are congruent. The two triangles are congruent. So we got two congruent triangles. That means the corresponding parts have to be congruent. CPCTC. All right, so there we go. Again, CPCTC, corresponding parts of congruent triangles are congruent. All right, so now we know this. What we can do is now we can say, okay, PK plus KL. So let me do those in red. PK plus KL has to be bigger than PL, right? That's the triangle inequality theorem, right? So yeah, the triangle inequality. Okay. Triangle inequality theorem. Remember, the two sides always have to be bigger when you add them together than the third side, right? All right, and then what do we end with? We end with what we're trying to prove, right? PK plus KM is greater than PL. It was greater than, what was it? It was greater than PL. KL, sorry. KM is greater than PL. So that's the proof statement, right? KM, yeah, plus KM is greater than PL. So what happened from step 9 to step 10? Well, it looks like KL got replaced with KM because of step 8, right? Because they're equal to each other, so we can replace them. So that's a substitution. All right, and that forms the end of the proof, guys. All right, so let's look at the last one. All right, so write another proof. So remember, the given is usually going to be the first part of the proof. The number 1 is going to be usually what's given. So let's do that. We don't have any other givens in the statement, so we have to go with that. So we're given that the two triangles are congruent. That was given to us. All right, so now it says AB plus BC is greater than AC. The two sides, when you add them up, have to be bigger than the third side, right? And same thing here. We got ED plus EC has to be bigger than CD. Okay, so that's the triangle inequality theorem. Okay. So now, notice that to get from step 2 to step 3, I have to subtract BC on both sides. Can you see that? And then for the other equation, I have to subtract EC, right, to get step 3. So that's a subtraction property of inequality. And then to get to step 4, I just have to combine. I just had to take step 3 and add DE to both sides. So basically, I added DE here to this side, and then I added DE to this side as well, right? But remember that DE is equal to CD minus EC, right? So then we can replace this with CD minus EC, okay? And that's what we did. So this part was equal to the DE, which I added from the left side. So that's addition. And then for step 5, what we have to do is, notice in step 5, we basically remove the CD there and then move the BC there. So we switch BC and CD. That is called commutative property, okay? Commutative property is when you say, okay, A plus B is equal to B plus A, okay? So when you switch them, that's called commutative property. In this case, commutative property of addition, because we switched them and it was addition that we switched, but that's neither here nor there. Just say commutative property. Number 6, what happened is we basically combined BC and we basically, so we basically did is we basically put BC and EC in parentheses like that, but then if I put in parentheses, then there's a negative there. So basically what I did is, okay, so let me write it out. So BC minus EC. I put it together, but there's a negative here, so I got to distribute the negative. And when I do that, this has to turn positive, right? Because if I distribute this here to this equation, I get negative BC and negative EC, right? Which is exactly what we have, negative BC minus EC in step 5. So basically what we did is distributive property. We distributed that, okay? So that's called distributive property. So distributive property, you know, is when you have, okay, A times B plus C. Distribute A to B and C. So A times B plus A times C. That's distributive property. And then we hardly use those, but those are properties that are there. And then number 7, if you look at the original diagram, AC plus CD is AD. Okay, so let's do that. AC plus CD equals AD. Well, that's a segment addition postulate. You take 2 segments and you add them together. So that's SAP. Okay, so that's segment addition. Segment addition postulate or property. All right, let me get rid of this now. Remember, the last statement has to be the proof statement, right? So proof statement is this guy, AB DE is greater than AD minus BE. Okay, so AB plus DE is greater than AD minus BE. So how did we get that? Well, what we did is we took step 6, right? And we took this and we replaced it with AD. And then we took the BC plus EC and we replaced it with BE, because remember it's equal to BC plus EC right there. All right, and then we just replaced it. So that's why we have that and that. So that's a substitution. All right, and that's it. We proved what we wanted to prove. Okay, those are the hardest ones of this bunch, is to do the proofs. Hope you guys found this useful, and thank you. Hope you learned something, and as usual, I'll see you in the next one.